Hi, we'd like to talk to you about LakeBench, a benchmarking suite of tasks that we developed for tabular data discovery over data lakes. This is meant for fine-tuning tabular representation learning systems. So our rationale for this is that as large language models have become more and more popular as a way of processing even tabular data, there is a lack of benchmark data to fine-tune and build models for data discovery. Most of the existing table representation learning systems target natural language tasks over tables, like question answering over tables, for example, or mapping columns to concepts. The focus of LakeBench is to target data discovery tasks because they are pretty important when you're trying to search for tables in a data lake. And in particular, we focus on the following three tasks: unionability, joinability, and detecting table subsets. Here's an overview of the different types of tasks we have within each subset. So we have a mixture of binary classification tasks, multi-label classification tasks, and regression tasks. And we have a mixture of data sources, such as existing benchmarks like TUS and Santos data, which are actually search benchmarks that we converted into a union benchmark and grouped them so that we would get many more examples. And similarly, we have things like wiki union, which are entirely new that we generated from Wikidata. We also have data from the European Central Bank being used heavily in this benchmark, both for joins and for unions. And in this case, we have economic data that has source information about what is unionable and what is joinable, and we use that to create the benchmarks. This should give you a sense of the total number of tables we have, the average number of rows we have, and some of these are very large, as you can see, and the total number of pairs that are available for fine-tuning tasks. This slide is basically to talk about the different kinds of data types we have in LakeBench. We have, tables that tend to be heavily string-focused. That's coming from TUS and Santos, down to cases where we have a lot of open data mixed with Spider, and that has very few string columns. To determine the ground truth, we used a mixture of synthesized data for building the benchmarks, as well as when we could get ground truth from sources, we used that. So, for example, in unionability for over Wikidata, we determined it by splitting entities of the same concepts and insisted that the attributes were exactly the same. We did not provide column names to make the task harder for the representational systems. In terms of the ECB data, when we were creating unionability, the source itself contains many, many different dimensions, and each data set can share one or more dimensions with other data sets. So we model this as a regression task where we could union data sets, and the likelihood that they would be unioned would decrease as you vary the total number of dimensions on which they could be unioned. And similarly, we have synthesized data in terms of ECB join, where the dimensions are specified in source, but we used column value overlap to determine whether these were positive or negative pairs. This is an example of generation from Wikidata. You can see that unionable columns are entities which are municipalities of Slovakia, and there are some attributes of those particular municipalities. And we can also see a new table which has a similar sort of information, but from Poland. So fundamentally, what we're doing here is using the ground truth in Wikidata to split up the tables into unionable and joinable tables. And here's another example from CCAN where this was entirely synthesized. We picked columns that looked like good candidates for a joint column based on uniqueness and certain attributes, like they don't have to be float values or booleans for that matter. We sort them, and then we try to make sure that we combine parts of the table. You can see the quadrants here. The diagonal quadrants would form negative examples, and the quadrants that are on the same row would form positive examples. Here are some baselines that we got on existing tabular representational systems, which are open source, and these are some examples of values we got for the different benchmarks. What is quite clear is that in some cases the systems are performing really well, like TUS Santos, but in other cases they are really quite poor, and there's a significant room for improvement. So the goal of this benchmark is to allow us to start building these sorts of models. If you find this useful, our paper can be found on arXiv, and we also have all of the data cleared by legal and available on Zenodo for anyone to use. Thank you.